So we're going to talk about completing the square. So you want to use completing the square if a quadratic function is not factorable. You can solve for x by completing the square. So in order to do that, you must write your quadratic in standard form. And remember, standard form is where you have an x squared term, an x term, and a constant term. You're going to move your constant to the other side of the equal sign, and you're going to divide by your a coefficient. You're going to determine the value needed to complete your square. Then you're going to factor your trinomial, and these factors will be perfect square trinomials because your row and column terms, those parentheses, those two factors, are going to be the same, which allows you to write your factor to the power of 2. Then you can take the square root of both sides and solve for x to find your x-intercepts, which are your zeros, which are your roots. So now we're going to look at a couple of examples. So the first one that I have is x squared minus 16x plus 15. So we're going to move our constant to the other side, and we're going to have x squared minus 16x. Now we're going to write plus a blank equals negative 15, because that's what I get when I move the 15 over and I combine it with 0. I have negative 15. And now we're going to put plus another blank. And in that blank, that's where we're going to write the constant that completes our square. So now we're going to draw a picture. I'm going to factor or draw the picture of x squared minus 16x plus blank. So I'm going to go ahead and draw my box for my x squared term. This would represent x squared. And now I want to think, how many rectangles can I draw that comes down and comes out from my x squared box so that I make a square? Remember, it has to be an even amount. So if I have negative 16x, I can split that into 2 even groups of 8. So I'm going to draw 8 lines. 8. And this is going to represent a negative 8x and a negative 8x. Because if I combine these negative 8x's together, negative 8x plus negative 8x, it should combine and add back to negative 16x. So now I'm going to try to figure out what number would I put here, what constant value could I put here in this box that would complete the square and make a perfect square trinomial. And that answer is 64. So I'm going to put 64 in all 3 of my blanks. So now I have completed the square. And what I'm really looking for is I'm really looking for those factors. So if I wrote my row and column terms, I would have x times x. Well, x times what is going to make negative 8x? That would be negative 8. And what times x is going to create a negative 8x? That would be a negative 8 also. And a negative 8 times a negative 8 is going to make 64. So my factors are x minus 8 times x minus 8, which I can then write as x minus 8 squared to the power of 2. And the reason why I want to complete the square is so that I can write factors to the power of 2, so I can use the square root method to solve for my solutions for this quadratic. So now we're going to actually work out our problem. So I'm going to take this trinomial and I'm going to rewrite it as our factors to the power of 2. So square root, x minus 8 to the power of 2 equals, and now I'm going to add my constants together. I have 2. I have a negative 15, that was the constant I didn't use, and then I added in my own constant 64 that completed my square. So I'm going to add those constants together. So negative 15 plus 64 is going to give me 49. And now I'm ready to take the square root so that I can undo that power of 2. And that's going to leave me with x minus 8. And now if I write 49 as, use that birthday cake method, I want to write the prime numbers of 49. So that would be 7 and 7. And I can make a group of 2 with my 7s. So that means the square root of 49 is 7, but in order to make this correct, I have to put positive, negative, and now I'm ready to write my plus minus my 2 answers. So x minus 8 is equal to a positive 7 x minus 8 is equal to a negative 7. So when I move my negative 8s over to the other side, don't forget they change sign. So that's going to be plus 8 plus 8. X is equal to 15, or x is equal to 1. And those are my solutions for my quadratic. So now we're going to look at our next example. Again, we're completing the square. So I want to move my constant over to the other side. It already is. So now I'm going to rewrite this as n squared minus 14n plus blank equals 11 plus blank, because I want to leave space for my constant to come in. And now I'm going to draw my picture. I'm going to draw my picture of n squared minus 14n plus blank. So now I'm going to draw a box for representing n squared. And now I want to think, how many rectangles would I need to evenly add up to a negative 14? And the answer is negative 7. So I'm going to draw 7 lines representing 7 rectangles. And I always write over it, that's a negative 7n and a negative 7n. And the reason why both of these have to be negative 7s is because negative 7 plus negative 7 is going to get me to a negative 14. And now I'm ready to figure out what constant would I need to make this a perfect square trinomial. What would complete my square? And hopefully you said 49. So 49 is going to complete my square. So I'm going to write 49 in all of my blanks. And if I write my terms for my rows and columns, that would be actually n times n. I'm used to writing x. N times what makes a negative 7n? That would be negative 7. And what times n is going to make negative 7n? Negative 7. And negative 7 times negative 7 does make a positive 49. So my factors are n minus 7 times n minus 7. But I can simplify that to n minus 7 squared, also known as n minus 7 to the power of 2. Now I'm ready to write my solution. So I'm going to rewrite my trinomial as my factors, because remember we want the power of 2 so that we can take the square root. So I'm going to say n minus 7 to the power of 2 equals, and I'm going to add my constants together, 11 and 49. So 11 plus 49 is 60. And now I'm ready to take the square root to solve for the value or the values of n. So take the square root of both sides. And remember the power of 2 and the square root cancel out. So I'm left with n minus 7 equals. And so now I want to write 60 using prime factors. Well, I know it divides by 5. So that's going to leave 12. And I can divide by 3. And that's going to leave a 4. I can divide it by 2. Which leaves a 2, and I can divide 2 by itself, which leaves me with 1. And now I'm looking for groups of 2 that I can remove from the square root. Well, I have a group of 2's that I can move out, so that's going to be 2 square root of, and my 5 and 3 are left, so I want to multiply those back together to get 15. And now I have a positive negative, because when I take the square root, I always have a positive or negative answer. And so now I'm going to write my 2 equations so I can solve for the value of n. So I have n minus 7 equals the positive 2 square root 15. And I have n minus 7 equals a negative 2 square root 15. And now I need to ask myself how to solve for n. Okay, I need to move my negative 7 in both equations over to the other side. So I'm going to do that. And I'm not going to forget to change the sign. But now I need to ask myself, can I combine? And no, if you say this answer is 2 times the square root of 22, you would be incorrect. If you say this answer is negative 2 times the square root of 22, you would be incorrect. You need to think of your square root as like an x. So if this was 2x plus 7, these would not be like terms. I could not make 9x. If this was negative 2x plus 7, I could not add or combine these terms together to get 5x. So because they are not like terms, you treat your square roots just like you would a variable. You have to leave these as separate terms. So my first answer is 2 square root of 15 plus 7. And my second solution is negative 2 square root 15 plus 7. And those are my solutions, my roots, my zeros. These are the values where the quadratic graph is crossing the x-axis.